Okay, so we'll start now the slope and deflection problems by using the direct method. So we'll be starting first with the direct method. So in this direct method, we will be seeing few standard cases, and if the problem comes in one of those cases, then we'll straight away use the formula and solve the question. So first we'll be taking case number 1. So in this case, so pay attention, it is about a simply supported beam. So now this is a beam, it is simply supported means this is a hinge support and this is a roller support. Now there is a load and the type of load is point load here. So the P represents the point load. Due to this point load, there is a deflection of the beam, and the beam after deflection or the deflected shape, deflected curve of the beam is like this. This is point A, this is point B, and this is point C. So clearly you can see the maximum deflection. The maximum deflection is present at the center. So this value is delta C. The slope at point A is theta A and the slope at point B is theta B. Now due to the symmetry of this beam, theta A is equal to theta B. Now if this kind of problem appears in the paper, or we can say if this kind of problem appears in front of you, then you have to straight away use the standard formulas. So now let me tell you, these formulas are derived from the double integration method or Macaulay's method. The derivation we will see it in the subsequent videos. Right now you just assume that you have understood the derivation and we have derived these formulas. Based on these formulas we have to solve the problems. So here now, what is the maximum deflection? The maximum deflection is present at the center, that is at point C, and the value of maximum deflection is PL cube divided by 48 EI. PL cube divided by 48 EI. Similarly, the slope at point A, this is equal to slope at point B, and the value of this is PL square by 16 EI. PL square by 16 EI, and this PL square by 16 EI, this will come in radians. So these two formulas now you have to remember. P we already know, P is the point load. What is the value of L, or what is L? L is the span of the beam. So this entire length is the L value. 48 is constant. E and I are the properties of beam. E is called as modulus of elasticity. And I is called as moment of inertia. Moment of inertia. Now sometimes in the problem a term is given which is called as flexural rigidity. So if in a question it is given the flexural rigidity of the beam is dash dash. So that means the value of EI is given. This product of E into I is called as flexural rigidity. So now by using this much information, if such a problem is given in the question, then you can straight away apply the formulas and get the answer. Now one thing to understand here other than these formulas is the conversion of the units. So the conversion of the units is most important. What I would recommend is first convert all values into SI units. Convert all values into SI unit. That is, convert the P value in Newton, the force value, the L value in meter. Similarly, this E value, this you should convert in Newton per meter square or Pascal, and I value, this you should convert in meter to the power 4. So how to convert this? This you have to practice it, or else I will prepare another video in which we will cover how to convert any unit into SI unit. So first, whatever the values are given in the problem, you convert them into SI units and then substitute in this formula. Don't substitute it randomly, otherwise the answer that you will get will be incorrect. So I hope it is clear. Same thing you follow it with the second formula also. So now the case 1 we have understood. Now in the next video we will directly see the problem on case 1. So you remember these formulas and then move to the next video.